Okay, let's continue to question 8. And question 8 is about parsing process. And part A, we need to find mean of xt. And xt is equals to the Poisson distribution from 0 to t. Okay. And this is equals to this. As you can see, this is Poisson distribution, and we times the distribution with k, and the domain is from 0 to infinity. This is the definition of discrete distribution of how to calculate a discrete distribution, the mean of the discrete distribution. Okay, in order to calculate this, we can start with the definition of distribution, of discrete distribution, actually. We know that this must be 1. This is the definition of discrete distribution, and is equals to this, right? So all we need to do is to times the variable k into here. So we just use the integer method to deal this problem. X equals to this, right? Just to let this here, and we take a derivative on both sides. And then the k variable comes. And another side is the same as this because it's e. And we times the t to both sides. And we get what do we want. Okay, and the answer is rho t. Okay, actually, to here we find the answer of part A. And in part B, we need to find the autocorrelation of T1, T2. And in order to get this, firstly, we can calculate the variance of xt. And the variance of xt can be calculated. Use the same method I just used in part A. Use the derivative again. Because in order to get variance, firstly we need to calculate the mean of xt squared. And now we need to get k squared and we just to take a derivative again in this expression, and we will find that this I'm sorry. Do we take a derivative of this again, and k squared comes, and we just times rho t to both sides again, and we times e power of minus rho t. Is equals to rho t plus rho t squared, and that's the mean of xt squared. So the variance of xt equals to, as we all know, is equals to mean of xt squared times mean of xt squared, mean of xt then square is equals to rho t. Okay. Now we can calculate the autocorrelation of T1, T2. Firstly, we can assume that T2 is greater than or equal to T1. So now xt1 would be xt1 minus xt0. I'm sorry, x0. Then xt2 minus xt1 are independent ideally. Now autocorrelation of T1, T2 is equals to mean of xt1 times xt2 and and they are independent, so is equals to rho times T1 plus rho T1 T2. Okay, we can find that if T1 is greater than OT2, it's easy to get that the correlation, autocorrelation of T1, T2. We just change the T1 to T2 here, because the calculation process is the same as when T2 is greater than T1. Okay. In summary, we can write the autocorrelation of T1, T2 is equals to rho the minimas of T1, T2 plus rho T1, T2. And that's it. Thank you.